All right. Good afternoon and welcome to Master Talker online class. If today is your first day of watching our video, please consider subscribing. Okay, let's continue with our work on probability. We have done the first video. This is the second video. So we are talking about theoretical probability. Now, theoretical probability is simply the probability calculated without the experiment being performed. You are not performing the experiment. Okay. In fact, the experiment is not being performed. I think you're even the one to do the experiment yourself. So look at an example. The first example said two numbers are chosen at random from 1, 3 and 6. Okay, then the now says you should find the probability that the sum of the two numbers is not odd. Is not odd. Okay, let us get the sum of the two numbers. We are to add 1, 3 and 6. The same number again, 1, 3 and 6. Let's get their sum. There, from there we'll now know the ones that are not odd number. So I'm having 1 plus 1, 2, 1 plus 3, 3, 1 plus 6, 6, 3 plus 1, 3, 3 plus 3, 6, 3 plus 6, 9, 6 plus 1, 6, 6 plus 3, 9, 6 plus 6, 12. Okay, now the ones that are not odd number, how many are they? The sum. This is not odd number 1, this is not odd number 2, this is not odd number 3, this is not odd number 4, this is not odd number 5. Okay, so a probability of not odd number, not odd, okay, can be got is what? 5 over what? How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 over 9. Okay, or probability of not odd number, not odd, okay, is simply 1 minus probability of odd. Don't forget that formula. So it is what? 1 minus probability of odd. How many odd do we have? 1, 2, 3, 4. We have 4 odd. That is 4 over what? Over 9. So if you do the math, you're going to have 9 minus 4 over 9, which is still 5 over 9. The same answer. Okay. So the next one said find number 2. Find the probability. Find the probability that a number selected at random from 41 to 56 is a multiple of 9. Solution. Okay, so probability of number selected from 41 to 59 is a multiple of 9. Okay, so I have 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56. Okay, so multiples of 9 is 9 times 1, 9 times 2, blah blah blah, like that. 9 times 4 is 36. 9 times 5, 45, 1. 9 times 6, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 953. That's all. So they are just to a number. Okay. And how many are they here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16. So the total number is what? 16. Or you simply say 56 that you have here minus what? 41, then plus 1. That's how to get it. So this is 15 plus 1, which is what? 16. And the multiples of 9 there is simply 2 numbers. So the probability of multiple is just what? 2/16, which is 1/8. As simple as that. So the next one, 1/8. So the next one, number 3. Number 3 said 2 fair die. Two fair dice. Okay, the plural is dice. 2 fair dice, each of 6 faces. Okay, 2 faces numbered 1, 2, 3, 4, 5, 6. Okay, are tossed once, comma, find the probability of getting a sum greater than 10. Okay, solution, just draw it. Plus, I have 1, 2, 3, 4, 5, and 6. I still have the same 1, 2, 3, 4, 5, and 6. Alright, let's get the sum. 1 plus, this is 1, 2, 3, 4, 5, and 6. 2 plus 1. Sorry, 1 plus 1, 2. What am I saying? 2, 3, 4, 5, 6, 7. You start from here. 3, 4, 5, 6, 7, and 8. You start from here. 4, 5, 6, 7, 8, and 9. Start from here. 5, 6, 7, 8, 9, and 10. Start from here. 6, 7, 8, 9, 10, and 11. Start from here. 7, 8, 9, 10, 11, and 12. Okay, so these are their sum, and they say the ones that are greater than 10. Greater than 10 I'm having here is 1, 2, and 3. Only 3. And how many are they? They are 6 times 6, 36. They are 36 in number. So probability of sum greater than 6. Probability of the sum greater than 6. Okay, should be equal to what? How many are they? 3 all over 36, which is what? 1/12. Probability is the simplest this thing you can do in school. Number 2. Simplest topic. Number 2 said if 2 fair coins, okay, are tossed once, comma, what is the probability? What is the probability that at least a head shows? Solution. Okay, so if you throw it, I'm supposed to have a head and a tail. A head and a tail. So head, tail, head, tail, head, tail, head, tail, 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 head, tail, head. So, sorry, head, head. So probability that at least a head must show is how many? 1, 2, 3. So they are 3 in number. So probability of at least a head is 3 over how many are they? 1, 2, 3, 4. They are 4 in number. Okay? So that is that. Or you say probability of what? You say 1 minus probability of only tail showing. So the same thing. Okay? So the next one. Next one said experimental probability. That's what we are entering. Sorry, empirical probability or experimental probability. The same thing. Let's enter empirical. Empirical or experimental probability. Okay? Empirical or experimental probability. Now, empirical probability is calculated using the result of an experiment that has been performed. Okay? You know that in the other one, we did not perform it, but in this one, it must be performed a number of times. So in experimental probability, we have that probability of what? The event, okay, is equal to what? F of E all over what? The summation of what? F. Okay, where F of E is the number of times the event occurred. The number where F of E, okay, is the number of times the event occurs. Okay. Now this of summation of F is simply the total number of frequency. Is the total frequency. Okay. So example. Now example go dey help us. So let's go by example. Example said, example number 1 said some families were measured by the number of children they have to give the following frequency. To give the following frequency distribution. Okay, we now have, this is the following frequency distribution. We have that this is number of children, and we have 0, and then we have number of families, So 0, I have 12. 12 families they don't have children. 28 families have just one child. 1, 2, 3, 4, 5 or more. 5 or more. Okay, they have that this is 2, 2, 8, 22. Okay, then I say using the information, using this information. Using this information. Okay, sorry, use this information. Use this information to calculate the probability that another family of this type will have number 1 2 children. Number 2, 3 or more. Number 3, let me call it I. Number 3, less than 2. Okay, so let's get that. So it's a probability of 2 children. Probability of 2 children. Probability of 2 children is what? 22 over how many are they? The number of children. How many families? Sorry, the number of families that have this. The number of families talked about, or the number of families that were measured. Okay, they measured how many families here? 12 plus this is in fact everything is 72. 2 plus 2, 4. This is 10, 12, 14, 34, 36, 46, 56. Is it up to 74? You can calculate it. So let's do it again. I'm having 30 here. 30. 30 plus 20, 50, 52. 52. 52 plus 8, 60. 64. So 64. So if you do everything, you have 11 over 32. As simple as that. Okay. So the next one, probability number B, probability of 3 or more. 3 or more. Okay. 3 or more is from here up. That is 8, 10, 12. That is 12. Okay. That is 12 over 32. 12 over 64. Sorry. Which will give you 6 over 32. 3 over 16. 3 over 16. Okay. So C or I. They say less than 2. Less than 2 means 1 and 0. That is 12 plus 28 all over what? 64, which will give you 30. 30 over 64, which is 15 over 32. Is it 30 or 40? What am I saying? Sorry, 74. Oh, I need to go and eat. So which gave me, the first one gave 11 over 37. 6 over 37. 20 over 37. So here is 40. Okay. So that is that for that. Let's move into the next one. So the next question said the edges of some pupil are given in the table below. This is ages and the frequency. 7. 5 people are 7 years. 8. 9 people are 8 years. 9. 7 people are 9 years. They say, what is the probability? What is the probability that a pupil chosen at random is not 8 years old. Okay, don't forget that probability of not, whenever you hear not, you must say 1 minus. So probability of not 8 years should be what? 1 minus probability of 8 years. As simple as that. Which is 1 minus probability of 8. How many people are 8? 9 people. 9 all over. The total number is what? This is 14, 21. Which is what? 21 minus 9 over 21. Which will give you... So what do you have now? 21 minus 9 is 11. 12. So 3 here is 4. 3 here is 7. Okay. So that is that. So now let's talk about the rules in probability. That is the addition and the multiplication rule. The addition and the multiplication rule. Okay, addition rule. Under the subheading addition rule, we have twin concepts, namely mutual exclusive and non-mutual exclusive. So let's talk about, under this addition we have mutual exclusive and we have non-mutual exclusive. So let's talk about the first one, the mutual exclusive. Okay, two events A and B are mutual exclusive if the occurrence of any of them excludes the other. Okay, let me write it down. You can write it: two events A and B are mutual exclusive. We call it mutual exclusive. Okay, they are mutual exclusive if the occurrence of any one of them excludes the other. So like they don't need each other. That means they don't have any intersection. It means that what? That the probability of A or B, okay, don't forget that I told you that all means addition, is simply the probability of the union A union B. Okay, that is, they don't have any occurrence between them. Okay, and you know that probability of A union B means it can be probability, this thing is taken as probability of only A plus probability of only B, then minus the probability of the intersection, probability of A intersection B. But in A intersection B, they don't have any intersection. A intersection B is empty. They don't have anything in common. So for mutually exclusive, we are having that is simply probability of A plus probability of B. Because they don't have any intersection. They are just happening on their own. There is no intersection between them. So we can represent that in a Venn diagram. Okay? We can present that in a Venn diagram. If we represent the Venn diagram, we're having that what? For mutual exclusive, we're having that this is for A and this is for what? For B. They don't have anything in common. So the probability of A happening or B happening is simply probability of A or probability of B, like that. And all means addition, probability of A plus probability of B. So note that. Why? Because they are mutually exclusive. So some example of mutually exclusive events. A said the events of going to school by foot or by car are mutually exclusive. You cannot say that you went to school by foot and equally went to school by car at the same time. It's not possible. You must choose one. Okay. The next one is that what? The event of cooking a particular pot of soup using stove or gas cooker. You cannot use the both of them to cook one food at the same time. That same food at the same time. Unless after if you cook this one small, you now come and cook this one again. So that is that. Okay. So let's take an example to that. Let's take an example to that to help us understand mutual exclusive events. Okay. So an example number 1 said that a haulage contractor has 3 type A, 2 type B, and 7 type C lorries available. Okay, for delivery. Okay, comma, all of which are used frequently. Then what is the probability that a lorry delivering a load will be a type A or C? Solution. Now, if you look at this event, it is mutually exclusive because you cannot be driving 2 lorry at the same time. So that is the probability of what? Lorry of type A or lorry of type C is simply probability of lorry of type A plus probability of lorry type C, which is what? Probability of lorry type A is what? 3 over how many lorries do this man have? 3 plus 7 is 10. 10 plus which other one? 10 plus 2 is 12. That is 3 over 12 plus for type C is 7. That is 7 over 12. So both of them is giving me 12. 3 plus 7, which is 10 over 12, which is what? 5 over 6. As simple as that. Okay. Number 2. Number 2. 2 dice. 2 dice are thrown at the same time. Then I say, what is the probability that the sum will be 7 or 11? Now, the sum cannot be 7 and be 11 at the same time, so they are mutually exclusive. It is either it is 7 or it will be what? 11. So what do we have now? We have 1, 2, 3, 4, 5, and 6, right? 1, 2, 3, 4, 5, and 6. So I have here 2, 3, 4, 5, 6, 7. Don't forget that I'm adding their sum. This plus this, this plus this, this plus this. 3, 4, 5, 6, 7, and 8. 4, 5, 6, 7, 8, and 9. 5, 6, 7, 8, 9, and 10. 6, 7, 8, 9, 10, and 11. 7, 8, 9, 10, 11, and 12. Okay, so the probability of getting a 7, look at them. This is 7. Hey. Then probability of getting 11 is 11. So probability of 7 or 11 is simply probability of 7 or probability of 11, which is what? Probability of 7 is 1, 2, 3, 4, 5, 6. 6 over 36 plus 1, 2, 2 over 36. So I'm having 6 plus 2 over 36, which is what? 8 over 36. And 8 over 36 is giving me 8 over 36 is giving me 2 over 9. Okay? 2 over 9. So the next one, probability is very simple. You just play with it. The next one, in a basket. In a basket of fruits, there are 6 grapes, 11 bananas, and 13 oranges. If one fruit is chosen at random, what is the probability that the fruit is either grape or banana? Okay. Now you cannot choose something and that thing will be grape and at the same time banana. So they are mutually what? Exclusive. So probability of grape or banana is simply probability of grape or probability of banana. So and probability of grape is 6 over the total. This is 20, 24, 30 over 30 plus banana is 11 over 30. So both of them is giving me 6 plus 11 over 30. So I'm left with 17 over 30. Okay. The next one. The next one said a ball is thrown. Okay, it's thrown at random from a box containing 6 red balls, 4 white balls and 5 blue balls. Determine the probability that it is red or white. Okay, now we want to determine the probability that it is red or white. Solution. So the probability of it is red or white, you cannot pick something and that thing will be red and at the same time white. So they are mutually exclusive. So it's probability of red or probability of what? White. Which is what? Probability of red is 6 over the total. This is 10, 15. 6 over 15 plus white 5 over 15. So I'm left with 6 plus 5 over 15. Which is what? 11 over 15. So As simple as that. Huh? Okay, white is 4. Sorry, white is 4. So that is 10 over 15, which is 2 over 3. That is 5 divided 2, 5 divided 3. Okay? So the next one. These are very simple problems. So the next one, there are 5 red. There are 5 red, 7 blue, 6 green, and 6 green biros in a pocket. Okay, in a packet. Okay, then they say, what is the probability of a boy picking a green or red biro closing his eyes? Solution. Now, this guy will pick, when he picks, it's either he picks a green or he picks a red biro. Okay, and he cannot pick one biro, and that same biro he picked will now be green and red. So it is mutually exclusive. So it will now be probability of green or probability of what? Red. So and all means to add. So probability of green will now be 6 over the total 11, 18, 6 over 18 plus red is 5 over the same 18, which is what? 6 plus 5 over 18, which is 11 over 18. As simple as that. Okay, 11 over 18. So the next one said the table below gives the marks scored by a group of students, okay, in a test. Use the table to answer the question below. And the question said, what is the probability? What is the probability of selecting from the group that scored 2 or 3? And this is the table. This is the mark. This is the frequency. Okay? Only one person scored 0, the frequency 1. 2 people scored 1. 7 people scored 2. 5 people scored 3. 4 people scored 4. And 3 people scored 5. Okay? So we need the probability of people that scored either 2 or 3. So nobody can score 2 and at the same time score 3. So they are mutually exclusive. So probability of 2 or 3 is simply probability of 2 or probability of 3. So which is what? Probability of 2 is 7 people scored 2. So 7 over the total number is what? This is 10, 15, 19, 22. So over 22 plus 3 is 5. 5 over 22. So I'm having 7 plus 5 over 22, which is what? 12 over 22, which is 6 over 11. 6 over 11. So the last question, but not the least. The last but not the least question said, a number is chosen. A number is chosen at random from the set. From the set 15, 16, 17 up to 32. Okay? Then I say what is the probability? What is the probability that the number chosen is a multiple of 7? A multiple of 7. Okay? B, prime number. C, prime number or multiple of 7. Prime number or multiple of 7. Okay? Solution. So we can list the numbers. I have 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, so multiple of 7 is 7 times 1, 7, 7 times 2, 14, 7 times 3, 21, 7 times 4, 1, 2, 3, 4, 5, 6, 7, 28, 7, that is all, that is just 2. So, and how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So, number 1, probability of multiple of 7 is simply 2 over how many are they? 18. 2 over 18. So 2 over 18 is 1 over 9. So probability of prime number. Prime numbers are numbers that only itself and 1 can divide it. So I have first of all the prime numbers. The prime numbers we have there are 17, 19, 21 is not a prime number because 3 can divide it. 23, any other one. 29 is not is 29 a prime number. 29 is a prime number. Nothing can divide 29. 29 and 31. So 1, 2, 3, 4, 5. So probability of prime number is simply 1, 2, 3, 4, 5. 5 over 18. So now probability of a prime number or multiple of 7 is simply it cannot be a prime number. Can it and equally be a multiple of 7? Is it possible? No. It cannot be a prime number and be a multiple of 7. Being a multiple of 7 means that 7 can divide it. And prime number is a number that nothing can divide. So it's simply probability of prime number or probability of multiple of 7. So which is what? Let me use for prime number 5 over 18 plus 2 over 18, which is what? 5 plus 2 over 18, which is what? 7 over 18. So as simple as that. So thank you very much for watching. Please subscribe, please, and share to anyone that needs to watch this video. God bless you.